Hello students, and welcome to the review lesson on midpoint and distance. So I have an example here to begin with that uses the Pythagorean Theorem, and it asks us to solve for the variable c. So we can just apply the Pythagorean Theorem, which says that the square of the hypotenuse, in this case c, is equal to the sum of the squares of the other two sides. So that means that c squared is equal to 16 plus 49, which is equal to 65. Okay. And to solve for c, you take the square root of both sides, so c is equal to the square root of 65. Now you would want to check for a way to simplify this radical down further, but it turns out this is as simple as it gets, so that is our final answer. So kind of a quick warm-up problem here using the Pythagorean Theorem. Okay, so let's move on to something using distance. So example 2 here is a question that tells us to find the distance between the point 1, 3 and 8, 12 on a coordinate plane. So for problems like this, I'd like to just draw the picture. Helps me visualize a little bit better. So we'll go 1, 2, 3, 4, and we'll increment these by 3's. So 1, 3 is about here, and 8, 12 is up here. And so we want to know the distance between these 2 points. In other words, what's the length of that line? Well, the best way to do this is to make a triangle out of it. In this case, it's going to be a right triangle, and we want to know what's this vertical distance here and this horizontal distance. But it helps if we write in the coordinates. So this is 8, 12, and this point here is 1, 3. Okay. So in other words, the horizontal distance is just the distance between the x coordinates, so 8 and 1, so that's 7 units apart. The vertical distance is just between 12 and 3, so that's 9 units apart. And so now we'll call this d since we're talking about distance. And we apply the Pythagorean theorem like we did in example 1. D squared equals 7 squared plus 9 squared. D squared equals 49 plus 81, which is 130. So that means d is equal to the square root of 130. And again, this is as simple of a radical as we can get. It really doesn't get any simpler than that, so that's our final answer. And the main thing to take away from this is that if you're trying to find the distance between 2 points, you simply create a right triangle out of it, find the distance of the 2 points horizontally, vertically, and use the Pythagorean theorem to find the actual distance between those 2 points. Okay, so that's one particular example. And so we're going to move on to the more general case and actually derive the distance formula. So let's take a very general case, and let's say I have some point here, and I'll call the coordinates here x1 and y1, and I have some other point somewhere in space, and I'm going to put it in this location, but it could really be any quadrant anywhere, and this has coordinates x2, y2, and we want to find this distance here, in other words d. Okay. Well, we can do the same thing that we did in the previous example where we create a right triangle and ask ourselves, what is the length of the horizontal component here? Well, it's just, again, the difference between each of the x coordinates. So this length here is x1 minus x2. And this length here, the vertical distance between these 2 points, is y1 minus y2. Now you may be thinking, what's the, does it matter if it's x1 minus x2 or x2 minus x1? It turns out it doesn't matter in the final calculations, and you'll see in just a bit. So now we can look at this again using the Pythagorean theorem, which is d squared is equal to the square of the length, but the length now is expressed using x1 and x2. So it's x1 minus x2 quantity squared plus the square of the other leg of the right triangle, which in this case is y1 minus y2 quantity squared. And you see, it doesn't really matter whether it's x1 minus x2 or x2 minus x1, because when you square the resulting quantity, you're always going to get a positive number. And so in the final answer, we take the square root of both sides, and we come up with d is equal to this expression here, which is x1 minus x2 quantity squared plus y1 minus y2 quantity squared, and the square root over the entire thing. And let's just reflect a little bit here, because a lot of times students, and I know myself sometimes, get wrapped up in trying to memorize formulas, remembering exactly all of the notation and everything. And it's good if you have the formula memorized or internalized. But if you ever forget, just think back and remember and remind yourself that this is really just a problem about getting a right triangle. It's really just a problem about using the Pythagorean theorem. Okay, we use these coordinates here in order to find the length of these legs. Okay, and that's where this formula comes about. So I'll put a big box around this, because this is a formula that we use quite often. You shouldn't commit it to memory, but if you ever forget, you can certainly derive it using the methods that we used here. So hopefully this is all review for you if you are in the pre-calc class. If you're in geometry or algebra, you should ask your teacher or watch one of the other videos for maybe a more in-depth explanation. Okay, so now we're going to extend the idea of the distance formula by trying to use the distance formula to find the equation of a circle in a coordinate plane. So let's define our circle and give it some names here. So let's start out with a point here, the center of the circle. We'll call that point C, and its coordinates are A and B. Okay, so we don't know what the coordinates is. We'll just use A and B to describe it. Now let's draw the circle here, and my circles get better and better throughout the year. So that one's not too great. Now let's say that we have a radius of a length r. Okay. Now one thing that we know about circles is that every single one of these points on the circle is the same distance from the center. That means if I draw another radius here, its length is also r, because the radius is constant for a given circle. So we want to see if can we get an equation that describes every single one of these points. Well, we can do that by applying what we know about distance. So let's say this is some generic point out here, x, y. Okay. So how do I get an equation that relates x and y? In other words, so that in the future, if I know the y value, I can somehow use the equation to find the x value. Similar to how we use linear equations with y equals mx plus b. We want to see if you have a point on a circle, you have a coordinate of x, can you use it to find y? And in order to do that, we have to write an equation. So let's name this point, we got this point x, y. And one thing that I do know for sure about it is that the distance between AB and XY is R. Okay, so I'll say that one more time. The distance between AB and XY is R. So if you remember our distance formula, so I'm going to make a note on the side here that we're just using the distance formula. And we know that the distance in this case is equal to r. And it's equal to the square root of the x-coordinate minus the other x-coordinate squared plus the y-coordinate minus the other y-coordinate quantity squared. Okay, so this is just from applying the distance formula, because we know that the distance between the center and the point on a circle is always the same. So this is the formula for any point on a circle, but it's generally written this way. We square both sides in order to get this equation here. Okay, So this is the equation for a circle on a coordinate plane. For you to understand, x and y are the generic points, and a and b are the coordinates of the center. So I'll write this. This is the center. Okay. And then r, not r squared, r is radius of a circle. Okay. And this equation is used very often in mathematics, especially in geometry, algebra 2, trig, and calculus and pre-calculus. But the idea is that it all comes from the distance formula. We know that this distance is always r, and we have a distance formula that we can substitute numbers into in order to help us get the equation. So we're going to try some examples here, and hopefully things will be a little bit more clear. So let's look at an example here where we are given the center of a circle, and we're given that the radius is 4, and we want to know what's the equation of this circle. So I'll just draw this picture here so that it'll help us visualize. So 1, 2, 3, 1, 2, 3, 4. Okay, it's important that we label your scale here. So 3, 2, that's where the center is. And the circle has a radius of 4. Okay. So in other words, for every point x, y on the circle, this distance here is always 4. Well, we can apply the equation of a circle. Let me remind you over here. It's r squared equals x minus a squared plus y minus b squared. Okay. So, and keep in mind that a and b are the coordinates of the center. In this case, the coordinates is 3 and 2. The radius is 4. So we have the equation 4 squared equals x minus 3 squared plus y minus 2 squared. And take this one step further and simplify it. You get 16 equals x minus 3 squared plus y minus 2 squared. And that's the equation for this circle. And so it's especially useful if you want to do something like, let's say you're given a point, so you have a question like, is the point 4, 8 on the circle? Well, if it is, then it should match this equation. If you substitute in 4 for x, 8 for y, you should get 16 once you do all this computation. If you don't, then this point is not on the circle. So we can check once we have the equation. So 16, put a question mark here, is that really equal to 4 minus 3 squared plus 8 minus 2 squared? Well, this would give us, this is 4 minus 3 is 1, square that is 1, 8 minus 2 is 6, square that is 36, which is not, once you add this up, this is clearly not equal to 16, so no. Okay. So once we have the equation of this circle, every point that is actually on the circle should satisfy this equation. If it does not satisfy this equation, it is not on the circle. And we can also check quickly by graphing that if we go to 4, 8 would be all the way out here, so it would not be on the circle. Alright, so I've got 4 problems here for us to work on, finding center and radius. And again, you should really hit pause at some of these problems, try it on your own, and then compare your solutions to mine. So let's start right away with the first one. And just a reminder, if I have a center at A, B, and I have a radius R, that means my equation is x minus a squared plus y minus b squared equals r squared. Okay. So here you can see that a must be equal to 2, b must be equal to 5, that means the center is 2, 5. And the radius, so this is actually r squared. Okay, so r squared is equal to 36. That means r equals 6. Take the square root of that. Next, for b, this is x plus 5, so we can rewrite this as x minus negative 5 quantity squared plus y minus 2 squared equals 49. So then the center is negative 5, positive 2, since it fits this pattern here. And the radius is just the square root of 49, which is 7. In part C, we have x squared plus y minus 3 quantity squared equals 64. So this is a little bit different because x isn't really subtracting anything here, so maybe it can be confusing sometimes to see what is the value of a, but it helps we can rewrite it this way. X squared is just x minus 0 squared plus y minus 3 quantity squared equals 64. Okay, so we can just rewrite this expression, and you'll see this a lot in pre-calculus and calculus where we have something and it's more convenient for us to rewrite it using 0 or using 1 or something like that without changing the value of the expression. So x minus 0 squared and x squared are just the same thing. But with this, it helps us to see that now the coordinate of the center has to be 0 and 3. And the radius, so this is the center, the radius has to be the square root of 64, which is 8. In our last example here, I'm just going to change colors here just to mix it up a little bit. We can rewrite this as x minus 0 squared plus y minus 0 squared equals 17. So that means the center is at the origin, 0, 0. And the radius is just the square root of 17. 17 is a prime number, so we can't really simplify it any further than that. So there you have it. 4 examples on when you're given the equation of a circle to be able to find where the center is located and the length of the radius. Okay, so we've talked quite a bit about distance formula and have seen some examples, and we've extended that to finding the equation of a circle. So let's talk about midpoint formula now. So the midpoint formula basically says given 2 points, and we'll call them x1, y1, and x2, y2. The midpoint is x1 plus x2 over 2 and y1 plus y2 over 2. Okay. And if you notice something that's a little bit different here, for the midpoint formula, it's giving you the coordinates of a point. So it's giving you 2 numbers, the x-coordinate and the y-coordinate. And this is basically like saying taking the average. So I'll make a note here. This is taking the average of each coordinate. And there is a proof for this. This is actually a geometric proof for this concept. But for the purpose of this class, and this is somewhat of a review, I'm not going to dive into the proof at this time. So you should either ask your teacher or look at some of the other videos in geometry on proving the formula for a midpoint. Okay. So let's take a couple examples. So here we have 2 points, 1, 5, and 4, 7, and I'll draw this out. Okay, it's important that you label your axes and your scale here. This is my origin. So 1, 5 would be right about here, and then 4, 7 is right about here, and we're looking for the midpoint, which is somewhere in here. Okay, so that's our midpoint. We want to find the coordinate of that. Well, just apply the formula. It's fairly straightforward. add up the two x coordinates. I'm going to call the midpoint m. So it's 1 plus 4 over 2. Add up the y coordinates and divide by 2. So it's 5 plus 7 over 2. Simplify that. And you get, that's 5 halves, or 2.5, and 6. Which you see that it's approximately, right, my picture's not great here, but this is about 2.5 and right about 6. So there you have it. An example on how to find midpoint using the midpoint formula. We'll take it one final example on what to do when you're given a midpoint and you're asked to find the other points. Okay, so we have an example here where it says M is the midpoint of line segment AB. If M has coordinates 2, 5 and A has coordinates 7, 12, what is the coordinates, or what are the coordinates of B? Okay, so this is a little bit different than the other examples because we know where the midpoint is at, we know one of the endpoints, and we're asked to find the other endpoint. So like many cases, I'll draw pictures. 2, 4, 6, 8, 10, 12, 2, 4, 6, 8, 10, 12. It's a little bit out of there, but 2, 2, so 2, 5 is right here, and this is M. Okay, so this is the midpoint right here. 7, 12, 4, 6, 8, 7, 12 is way up here. And that's the coordinate of point A, so that's up here. And what we are looking for is, what is the coordinate of point B? And we know B has got to be somewhere down here because M is in between A and B. So let me just neatly as I can write in the coordinates here. So this is A up here, that's coordinate 7, 12. M right here has a coordinate of 2, 5, and B has a coordinate of something. So x, y. We don't know what x and y are for, what value they are, so that's actually what we're trying to solve for. So let's apply the midpoint formula. I mean, we know that the midpoint, right, is x1 plus x2 over 2 and y1 plus y2 over 2. And let's try to substitute in some numbers here as much as we can. I mean, let's call A here x1 and x2. So let's make this x1, let's make this y1. Okay. So we know, and this is just x. Okay, so we know that so we know that 7 plus x divided by 2 is one of the coordinates, and 12, that's this known coordinate here, plus y, that's the missing coordinate here, over 2 is the other coordinate. But we also know that it has to be 2, 5. Right? In other words, this point here, 7 plus x over 2 and 12 plus y over 2, that's really, that's really 2, 5. So these two expressions have to be equal to each other because they are both the x coordinates of the midpoint. These two expressions also have to be equal to each other. And so now we just have two equations that we need to solve. So we have 7 plus x over 2 equals 2, and 12 plus y over 2 equals 5. Solve for this. 7 plus x equals 4, x equals negative 3. 12 plus y equals 10, y equals negative 2. And so we know then that B has to have coordinates negative 3 and negative 2. And if we check here, it looks approximately right based on the picture that we have. B is in the third quadrant there, and its coordinates are both negative, so that makes sense. Okay, so this is just a case of applying the midpoint formula and then solving two relatively straightforward equations.